Okay, next we have a binomial theorem question. So here's the binomial that we're talking about in the question. And it says determine all values of n for which the expansion has non-zero constant term. So firstly, let's write this like this. This is what I generally do. Let's write this as an exponent. This is x to the power negative 1 to the power of n. Here is the formula from the formula booklet, and in general we use this part of the formula for binomial expansion. It's the general term. So the general term for this expansion is going to be n. We don't know n, so it's going to be n c r. So n c r. In this case, a is this to the power of n minus r times this one, negative half x to the power negative 1 to the power of r. Okay, we want a constant term, so we want to, we don't care about the coefficient, but we want the power of x to be 0, right? Put a blank here on a, it doesn't really matter, but basically the exponent has to be 0 for it to be a non-zero constant term. Okay, for it to be a constant term. So let's figure this out. Let's expand this here. We're going to have n cr. That's never going to be 0. So we're looking for the non-zero constant term. Let's just take a look at what happens when we expand this. 8 n minus r x to the power of 3n minus 3r. And this is going to be, we don't really need to care about this part actually. We just need to like analyze the exponents here, okay? So for the constant term to exist, we just look at the x's here. I kind of messed up my writing a bit. This should be an r, of course, and this is an n. Don't get them confused. This one's a r over here, so they kind of all look the same. But just looking at the exponents, this means 3n minus 3r. And exponent laws say if you multiply these, you add the exponents. So you're going to have a minus r has to be equal to 0. So we're just looking at the exponents. Okay, we want to see when this happens. So we have 3n equals 4r. Okay. Or in other words, when n equals 4/3 r. Okay. So the key to this problem, I guess, is n has to be a whole number in this binomial expansion, right? N has to be in positive integer. So that only, so n is in z plus only when r equals 3 or when r equals 6, when r equals 9, just basically multiples of 3, right? Okay, and then when we have r equals 3, 6, or 9, n has to be equal to, well, if that's 3, you get a 4, and if that's a 6, you get an 8, okay? So you get basically multiples of 4, okay? N must be a multiple of 4. According to the mark scheme, this is all you need to write to get the full points. Okay, multiple of 4. If you want to write that algebraically, you can write n equals 4k. Is there a k in the question? No, so I could use k. 4k, where k is a positive integer that generates 4, 8, 12, and so forth, right? But you can just write your answer like this, and that's perfectly acceptable.